Okay, so with multiplying matrices, we did addition and subtraction. Today we're going to focus on multiplying. And when you multiply matrices, if you're doing what's called scalar multiplication, you're just multiplying by some constant. So basically, it's kind of like the distributive property, if you will. You're going to multiply by one number, one constant, all the way through the matrix. So these ones are really pretty simple. When you look at this, you take a 2 by 2 matrix, right? The 10, -1, 2, 5, that's a 2 by 2. And you multiply every piece of it by 3, so you still end up with a 2 by 2. You're not going to get any new pieces to it. But basically, you're going to go 3 times 10 is 30. 3 times -1 is -3. 3 times 2 is 6. And 3 times 5 is 15. Okay, so that's the simple version of multiplying matrices, where you just take a constant and you multiply it by everything. So let's say they give us two matrices here. They give us A and B, which are both, what are the dimensions of A and B? Rows by columns, right? 1 by 3. So those are 1 by 3 matrices. We're going to multiply them by a constant. So 3 times A and 2 times B, right? That means we are doing 3 times A. I'm not going to rewrite it. I'm just going to write the product of it. So we get 3 times A is going to be 3 times 2, so 6. 3 times -1, so -3. And 3 times 3, which is 9. Okay, so that's 3A, right? That's this one. Then we're going to subtract 2B. What would 2B be equal to? Yep, 0, 20, and -8. Okay. Notice I didn't do -2 times everything. It's just subtraction that's happening between them, right? This is not, don't think of this as a -2 right now. Think it of as subtracting. This is not right. Think of it as subtracting and then a +2 times everything, okay? So now from here, this you already know how to do, right? We just subtract our corresponding pieces. So what's going to go, well, first of all, the dimensions stay the same, right? A 1 by 3 minus a 1 by 3 is going to be a 1 by 3. What's going to go in that first spot? That's a 6, right? 6 minus 0 is 6. Then what? -3 minus 20. So a -23. And then last one, 9 minus a -8. What's 9 minus a -8? +17, right? So minus a negative becomes plus a positive. You get that positive answer. So this is 3A minus 2B. Does that make sense? Okay, now look at letter B. We're taking half of B and then adding A to that. What do you suppose half of B is? 1/2 times all those B terms, right, or elements. So half of 0 is 0. Half of 10 is 5. Half of -4 is -2. So that's 1/2 B. And then we're going to add to it our A, which doesn't change, to -1, 3. So when I add those together, what do I get? Zero plus 2? 2. 5 plus -1? 4. And -2 plus 3? 1. Thank you. Okay, so it looks like that. Questions on those? I feel like those are pretty straightforward. Usually the simple ones, those are the here, free points on the quiz or the test. As long as you're taking your time and not rushing through it and making silly positive and negative mistakes. Honestly, you guys, where most of the mistakes happen in matrices is positives and negatives. People just rush through and then they write the wrong thing down and then it affects everything. So take your time. It'll be great. Okay, example 3. Getting a little fancier now. What do you suppose you do first here? 4x plus 2 times the matrix 3, 4, negative 2, 1 is the matrix 10, 0, 4, 2. What? Distribute, right? Take that 2 and multiply it by everything is your first move. So we're going to do this first. Okay, so it's 4x plus the matrix 6, 8, negative 4, and 2 is equal to what is over there. I'm not even going to write it right now. 10, 0, 4, 2. What would your next move be? Subtract that matrix. We're going to take this one away. Take away 6, 8, negative 4, and 2. So we're going to do that over here too. 6, 8, negative 4, and 2, and subtract it. So I'm just going to write that down here. This stuff's gone now. So we have 4x equals, so here's what you're looking at. 10 minus 6, right? That's going to give us 10 minus 6 is 4 right here. Then you move to your next spot, top right with top right. So 0 minus 8, you get a negative 8. Next spot, what do you get? Bottom left. 4 minus a negative 4 would be 4 plus 4, so you get an 8 there, positive 8, right? 4 minus a negative 4. And then last spot, 2 minus 2, you get 0. Are we done? What do we got to do? Divide by 4, right? So if 4x equals this, let's divide everything by 4, right? So this whole thing is getting divided by 4. So x is going to be 4 divided by 4 is 1, negative 8 divided by 4 is negative 2, 8 divided by 4 is 2, and 0 divided by 4 is 0. So you end up with the matrix 1, negative 2, 2, and 0. Questions on any of that? Okay. If you've checked out, check in, because here's where it gets fancy. Matrix multiplication, first of all, you have to show your work on this stuff. You cannot just write a number down for me, mostly because I need to know if you're not understanding it, where you're going wrong and what it is you're doing, and you need to know where you're going wrong and what is going on. So on quizzes and tests, on the homework, show me what you're doing, okay? Here's how it works. In order to multiply matrices, the inside numbers of your dimensions have to be the same. So, for instance, if I take matrix A times matrix B and it's going to equal matrix C, I have to have these two be the same. This one doesn't matter, this one doesn't matter, but those two middle numbers, whatever, not coordinates, dimensions you have there, they have to be the same. If they're not, you cannot do it, okay? What happens is when those are the same, they end up just going away and you're left with an M by P matrix. Okay, so whatever your first number and last number of your dimensions are, that will be the dimensions of your new matrix. Okay? Matrix multiplication, I know normal multiplication is commutative, right? 2 times 3 equals 3 times 2. Matrix multiplication is not that way. So if I take A times B, I'm going to get a matrix, whatever that matrix looks like. If I take B times A, it's going to be a different matrix. They are not commutative. So it does matter the order you do it in. So just make sure you're doing it in the order that is given or asked, depending on what the question looks like. But here's what you do. Okay, it's a little fancy. I'm going to try to color coordinate here Hopefully that makes the most sense to you. The first thing you should always do when you're trying to do matrix multiplication is look at the dimensions, okay? What are the dimensions of my first matrix here? 2 by 2, okay? This one's a 2 by 2. What are the dimensions of the second matrix? 2 by 2, okay? So here's what you look at. If these two numbers are the same, which they are, you can do the multiplication. What are the dimensions of your final answer going to be? 2 by 2, whatever's left, right? So your answer should be a 2 by 2. So if you want to set it up as a 2 by 2, you can. The tricky thing is to show your work, you need more space. So I would set it up, it's a 2 by 2, but I would make it pretty wide because you're going to do some work inside of that 2 by 2. Okay? Okay, so here's how it goes. It's kind of fun. I've always, this was the thing in high school that I was like, oh, I like doing that. How you do it is you take the first row in the first matrix and the first column in the second matrix, okay? So it's row by column, and then row by column, and then row by column, and then row by column. So it's going to be, for instance, this row with this column is going to go right here. Okay, first row, first column goes in that first row, first column spot. Here's what you do. It's pretty simple. You are going to multiply -1 times 1. Okay, so that's a -1. And then add to it the product of the other two. 3 times -3 is a -9. Okay, so that first spot in your answer, -1 plus -9 is -10. Okay, new color, new spot. I'm going to go blue here. If you want to get this spot right here, that's the top row, right column. So you go top row, right column, and you do the exact same thing. So it's going to be -1 times 4 is a -4. And then 3 times 5 is 15. And we always add them together. Okay, you always multiply and then add those two things. So -4 plus 15 is going to give us an 11 over here. Is that making sense so far? So if I want this, which row in our first matrix are you using? Top or bottom row? Bottom row. And which column in the second matrix? First column, right? So this is, second row, first column. So you go second row, first column. Okay, which means we are doing 2 times 1 is 2, and -4 plus times -3. -4 times -3 is a positive 12, and we're adding those together, so that will be 14. Okay, so without doing all the highlights now, what's going to go here? What times what? Yeah, bottom row. So 2 times 4, right? 2 times 4 is 8. Plus what? -20. -4 times 5. -20. So 8 plus a -20 is a -12. And that's your answer. Okay? When I say show me your work, I want to see this. I want to see what you added, how it multiplied, and then what you added together. Okay? So I know it feels tedious at times, but I want to see your work. Show me what you're doing. So like on that last one, okay, on this 8 plus negative 20, we're taking to get this spot, right? That's the bottom row and the right column spot in our answer. So we take the bottom row and the right column, and you just go in order. The first with the first. So 2 is the first in the row, 4 is the first in the column. You multiply those together, you get 8. That's how we got this 8, okay? Then the second with the second is negative 4 times 5 gives you a negative 20, okay? Okay, take a look at this next one. Now this one looks a little different, right? They're not equal matrices. They're not the same size. What are the dimensions of your first matrix? That's a 2 by 3, okay? So you have a 2 by 3 here. What are the dimensions of that second matrix? 3 by 1. Okay, so notice our middles are the same, which is good. That means we can keep going. What is your answer going to be? What dimensions? 2 by 1, whatever you're left with. So you're going to have a 2 by 1 matrix. That means 2 rows, right? But only 1 wide, okay? 2 by 1. Okay, so I'm not going to put the back end of that on yet. So if it's a 2 by 1, that means we have a number here and a number here in our final answer, just 2 numbers, right? Okay, so let's look at how we can do that. We want our top row, first column, to be from the top row, first column. So now we have 3 numbers that we're working with, but it's the exact same process. You multiply and you add, okay? So it's going to be 2 times 2, so 4, plus negative 1 times 1, so negative 1, plus 3 times 5, or 15. That makes sense? Top row, first column, only column, right? All right, so on bottom, give me the show your work part. What comes first? 4 times 2, so 8. Then what? 0 times 1, second with second, so 8 plus 0, plus what? Plus 5. 1 times 5 is 5. Okay, so that's your process, and now you just simplify it. On top, 4 plus a negative 1, that would be 3, plus 15 is 18. 8 plus 0 plus 5 is 13. So this is your answer. Pretty good? Okay, you do the next one. Example 6. Give it a go. See if you've got it. Remember, always check. Are they the right dimensions? Can you tell me the dimensions of your answer real quick? 3 by 1. You should get a 3 by 1 when you're done. Anyone got an answer? What's your first number in your answer? 9. Yeah? What comes next? 10 and 24. 9, 10, 24 is what you should get. So if you take a look at this is a 3 by 2. This is a 2 by 1. These are the same, so we're good. If these aren't the same, by the way, you're just going to write does not exist. You don't have to do any math. You just say D and E if they're different. So these ones, it does exist. So your answer is going to be a 3 by 1. Right? 3 tall, 1 wide. Okay, so you take first row, first column. So it's going to be 2 times 4 is 8. 1 times 1 is 1. You're always adding. So 8 plus 1, okay? Second row, first column. So 3, negative 2, and 4, 1. You're going 3 times 4 is 12. Negative 2 times 1 is negative 2. And then last row and that same column, 5 times 4 is 20. And then 4 times 1 is 4. So simplify that. You get 8 plus 1 is 9. 12 plus negative 2 is 10. And 20 plus 4 is 24. Okay? Okay, last one here. And I just want you to see evidence of why these are not commutative. Okay? This one is what dimensions? The first matrix. 1 by 3. Okay. What are the dimensions of the second one? 3 by 1. So if we look at this, those are the same. So my answer should be a what? 1 by 1. You have one number. Okay. But flip that. If they rearrange these and they put the 3 by 1 first and the 1 by 3 second, what are the dimensions of that answer? 3 by 3, right? So they are not commutative. Make sure you do them in the order that they're given and you'll be golden. Okay, so we should get a 1 by 1, which means we're taking all of this with all of this just in one shot, okay? So it's going to be 6 times 4, or 24, plus what? What comes next? 5 times negative 2, right? So negative 10 plus, God bless you, 10 times negative 1, so negative 10. So 24 plus negative 10 plus negative 10, you get a matrix of 4. Okay, so just always double check this. Make sure you know my answer should be a 1 by 1. Oh no, I got a weird format. That's not a 1 by 1, so you can double check it. That's usually helpful. Any questions on that? Yeah, and then maybe just make a note if it's not the same middle dimension. You're just going to write does not exist. Okay? If you can't do it, nothing to do. All right.